Cloud computing is a general term for anything that involves delivering hosted services over the internet. These services are divided into three main categories, also known as types of cloud computing. What are these three categories? How do they differ from each other? What are their use cases and examples? All of this coming up in today's video. Hello and welcome back to the Tech Blackboard. In today's episode, we are going to learn how to describe infrastructure as a service, also known as IaaS. Then we will see how to describe platform as a service, also known as PaaS. Then we will see how to describe software as a service, also known as SaaS. And in the last section, which is section 1.3.4, we will see how to identify appropriate use cases for each cloud service, IaaS, PaaS and SaaS. Please note that I will cover the examples and use cases of each computing model together with their respective section. This means that there will be no separate section 1.3.4. I have clubbed all what you need to know for section 1.3.4 in the earlier sections. Before we directly jump to understand the different cloud delivery models, it will be good to understand how exactly the IT infrastructure is built on-premises. And by on-premise, I mean the IT infrastructure which is located within the physical confines of an enterprise, often in the company's data center, as opposed to running remotely on hosted servers or in the cloud. Okay, so now let's assume that you are a big construction company and you want to keep up with the modernization. So you want to host your website or application, and for that you must build an entire IT infrastructure. So let's build an IT infrastructure layer by layer. So now what do you think would be the first element in building an IT infrastructure? The very first thing that you will need to build an IT infrastructure would be to purchase some servers with some CPUs and some core memory. So now that you have some core computing strength in terms of these servers, in order to run your application, the very next step is the need to connect all these servers, and probably all these servers should also be connected to internet. And for that, we will need networking infrastructure. So networking infrastructure includes the interconnection of all these servers along with the internet connectivity. Okay, so far so good. Now that you have servers and network, but there is no server that can come alive without a good storage. So here comes the storage. Now storage can come in multiple different flavors. It could be HDD or hard disk drive, or it could also be SSD, which is solid state drive. Now we have all the basic components of our IT infrastructure. However, in order to ensure the best utilization of hardware, you must bring in some virtualization software. So here comes our virtualization. Now this virtualization software will enable you to run multiple virtual machines on a single hardware piece and have the ability to host multiple applications on those virtual machines. The beauty of virtualization is that even if the underlying hardware is same, but it still maintains the total separation of environments and application. So now our IT infrastructure is taking a good shape, but still there is a very important component missing, and that is none other than the operating systems. So here comes our operating system. There are many operating systems available in the market. The two prominent ones are Windows and Linux. So now what have we got until now? Until now we have got all our core hardware and operating system. It is right time to bring in the middleware. Now middleware typically means all the software additions that you would need in order to run the system or the application itself. For example, we have our middleware as database or messaging service. Then on the top of middleware, we normally have runtimes. So runtime is another layer of software which will host your application. For example, if this is a web application, this could be IaaS or Nginx or Apache. In case it's a container-based application, we would need a Docker runtime. Okay, so until now we have come a long way. Our hardware is in place, our operating system is there, our middleware is there, and our runtimes are also ready. What next? The next is our data and application itself. So basically it's the application and the data for which we did all this hard work of building a core IT infrastructure. So now we can host our application or our website for our construction company. That will surely boost our business to new heights. Now that you understand the core pillars of any IT infrastructure, let me categorize all of these components. So the bottom of this entire IT infrastructure is categorized as infrastructure. which includes storage, network, servers, and virtualization. On top of this core infrastructure, we have platform. So the platform includes operating system, middleware, and runtimes. And last but not the least, we have our service layer. The service layer includes the application and the data that is consumed or generated by the application itself. So the first four layers from the bottom, that includes storage, network, servers, and virtualization, are directly related to hardware and virtualization. And that's why this can be grouped as infrastructure layer. Moving on, the next three layers, which includes operating system, middleware, runtime, all these three can be grouped as platform layer. And then the top two layers, which includes data and application, these two layers are your actual business application or website and the data that your application holds. And thus, these two layers can be categorized as service layer. I hope you can understand the basic layers of any IT infrastructure and categorization of all of them. Now at this point, I want to reiterate that we are setting up all this IT infrastructure on-premises. So it goes without saying that the ownership to maintain all these layers, the infrastructure layer, the platform layer, and the service layer lies with you or your company. And that's exactly why this is called on-premises. Now let's look at some key details on on-premise IT infrastructure. So as I just mentioned, all the components are maintained by you or your company. There is absolutely no ownership of Microsoft to maintain any of these components listed on the left-hand side. Now let's try to understand where could this on-premise model be best suitable for. So we can see that on-premise is best suitable when you have old or legacy technologies, or you have some operating system or middleware that is not supported by cloud. However, by all means, I want to say that cloud is including more and more operating layers and middleware. So the room for unsupported operating system or middleware is thinning by every day. The next reason for on-premise could be the security reason. So for example, there could be a legal security constraint that you want to store all your data on premises. And for these kind of reasons, you can go for on-premises. Moving on, let's look at some of the benefits and use cases of on-premises IT infrastructure. So the first core benefit of on-premise infrastructure is that you can operate the on-premise infrastructure without using internet. Although these days, internet is a core element of any IT infrastructure. However, you can still operate the on-premise without the internet. And then of course, as I already mentioned, that on-premise IT infrastructure provides you a greater security. And not to forget, it also offers a greater control over your server hardware. Even though there are benefits of on-premise IT infrastructure, the problem with on-premise IT infrastructure is its huge capex and its limited ability to scale itself based on the business demands. For example, if there is a sudden surge in your business, there might be a seasonal sales, offers, or discounts, and due to that, there is a large volume of customers that are coming on your website, and this can literally cripple your website and bring your business to knees. And not to mention, this will make you lose a lot of business, lot of money, and top of all, you will lose customer goodwill. And all these problems because of the inability of on-premise IT infrastructure to scale quickly. And that's exactly where the cloud delivery models come into picture. So let's start understanding the cloud delivery model. The first model that we will understand is IaaS, or Infrastructure as a Service, and this is our section 1.3.1. And as you can see on the left hand side, we still have all the core components of any IT infrastructure. We have infrastructure layer, we have platform layer, we have service layer. Now let's understand how the responsibility of maintaining these layers is divided between you, your company, and Microsoft. So now you can see that in Infrastructure as a Service, or IaaS, the responsibility to maintain platform and service layer is with you or the company or the enterprise. On the other hand, the responsibility to maintain the infrastructure layer lies with Microsoft Azure. Now let's look what this IaaS is suitable for. So we can see that IaaS, or Infrastructure as a Service, is suitable for lift and shift migration. It is also suitable for test and development. Then we can also see that IaaS is suitable for storage, backup and recovery, web apps, and high performance computing. Moving on, let's look some of the benefits of IaaS. So IaaS helps you reduce the capital expenditures and optimize cost. It also increases the scale and performance of IT workloads, increases stability, reliability, and supportability. Not only that, IaaS also improves business continuity and disaster recovery. It enhances the security of your overall IT infrastructure, and then it also helps you innovate and get new apps faster to the users. Now let's look at some of the examples of IaaS. So in Microsoft Azure, services like Azure Virtual Machines, Azure Disk Storage, Azure Networking, and a lot of others mentioned here comes under the umbrella of Infrastructure as a Service. So these were all the details about Infrastructure as a Service or IaaS Cloud Service Delivery Model. It is now the time to understand Platform as a Service, also known as PaaS, and this is our section 1.3.2. Again, we have all the elements of the IT infrastructure. Let's see how the responsibility of maintaining these elements are distributed between you and your company. So here you can see that in Platform as a Service, it's only the service layer that you or your company have to maintain. So you or your company only take care about the application and the data, while Microsoft take care of platform and infrastructure layer. So basically, Microsoft will now be responsible for the runtime, middleware, operating system, virtualization, servers, network, and storage. Now let's understand where this PaaS is best suitable for. So PaaS is best suitable solution where you want to host your application on a certain platform. As I gave you the example of a website, if you have a website, you do the coding and then you need a runtime to host your web application. It could be IaaS, Nginx, Apache, or Docker. Similarly, PaaS is also very suitable for web apps and mobile apps. Moving on, let's look some of the benefits or use cases for PaaS. So PaaS or Platform as a Service helps you gain access to the sophisticated applications. And the best benefit of PaaS is that you only pay for what you use. And this is also known as pay-as-you-go subscription model. Moving on, the PaaS also allows you to use the free client software, mobilize your workforce easily, and access the app data from everywhere. Now let me give you some examples of PaaS offering in Microsoft Azure. So here you can see there is a plethora of services that you can use as PaaS offering in Microsoft Azure. We have Data Lake, we have app services, we have API management, we have Document DB, Service Fabric, Azure SQL, Azure Active Directory, and a lot of others. It is now the time to understand Platform as a Service, also known as PaaS, and this is our section 1.3.2. And now in Software as a Service, I have shown that the responsibility to manage all the layers, the service layer, platform layer, and infrastructure layer lies with Microsoft. Let's look at it in more detail. So here you can see that in Software as a Service, you or your company need not to maintain any layer of the IT infrastructure. The complete responsibility to maintain all the layers lies with Microsoft Azure now. However, here I want to give a little disclaimer. When I say that all the responsibility to maintain all the layers lies with Microsoft, you should also understand that this is a little oversimplification of the concept. Because in real life, sometimes you can still be responsible for the data that your application generates. For example, who access your data, what are the different authorization level on your data, that is still maintained by you. However, just to simplify the concept, let's say the responsibility lies with Microsoft. Now let's see some of the scenarios where SaaS is most suitable for. Now here you can see that Software as a Service or SaaS is suitable for application development and AI. AI is nothing but artificial intelligence. Then it is also suitable for cloud migration and modernization. It's also best suited for data and analytics, hybrid cloud and infrastructure, Internet of Things, and lastly we have security and governance. Now let's look some of the business cases or benefits of Software as a Service. So similar to PaaS, Software as a Service also helps you gain access to the sophisticated application. It also enables you to pay for what you use or pay as you go model. Then it also lets you use free client software, mobilize your workforce easily, and access the app data from anywhere. Now let's look at some of the examples so that you understand the Software as a Service a little more better. I'm pretty sure that looking at the examples, you might be scratching your head. Really, this is Software as a Service? Because I'm sure that you are thinking that I've been using these services for a lifetime now. But trust me guys, all these services like Outlook, Skype, OneDrive, or Office 365 comes in the umbrella of Software as a Service. And I hope now you will understand that why I was saying that sometimes you are still responsible for the data that you generate in software as a service. Now let me sum up all the concepts that we just learned in the previous slide, but in a slightly different manner. So as I showed in the last slides, all the components that comes under the infrastructure layer, for example, virtual machine, compute and storage, network or physical data center, all this can be categorized as infrastructure as a service. Then moving on, all the components that were present in the platform layer, they can be categorized as platform as a service. And lastly, your business application and your data that were categorized as service layer, that can now be categorized as software as a service. And in this episode, I present to you a different perspective and compare each of these cloud computing models side by side, and we will also understand how they're different from the on-premises data centers. Coming to this example, on the very left, you can see major layers with different components used to build any data center. At the very bottom of this layer, you can see that we have storage, network and servers. As we move up in the list, we start to shift our focus from hardware layers to the software ones. Now the next important layer is virtualization. But for now, just understand that virtualization is a technology that stimulates hardware functionality to create software-based IT services like application, servers, storage and networks. On top of virtualization layer, we have operating systems like Windows or Linux, middleware, runtime, and then we have our application layer that primarily consists of database and the front-end application. So when it comes to your on-premises data center, it is your responsibility or the company's responsibility to maintain all these layers and all these components. In contrast to this, when we move from on-premises to the cloud solution, the very first choice for most is IaaS or infrastructure as a service. Now here you can see the bottom 4 layers, the responsibility to maintain or procure new storage devices, create networks, setting up servers, and in fact virtualization is now the responsibility of cloud providers like Azure, GCP or AWS. In the coming episode, I will also tell you what different kind of virtualization techniques are there and how they are used in cloud technologies. So the beauty of IaaS or cloud is that you or your company is now free from big responsibilities of setting up huge data centers. You can offload this responsibility to a cloud provider and focus more on the solution or the application. So basically, you focus more on what operating system is needed, or maybe you decide on middleware or runtime needed to run your database or host your application. Your focus is now on more productive tasks for your business, and you pass the mundane and heavy activities of creating and maintaining data centers to the cloud provider. So life is getting better and less complex as we move deeper to the cloud solution. Now let's check out the PaaS or platform as a service. Now here you can see that you or the company, you just now need to focus on your data and your application. Here in the PaaS, you can see that the cloud providers delivers the hardware and software tools to the users over the internet, and you as an end user use them for your application development and pay for it. Perfect. So what about SaaS? Well, as per the definition, SaaS is software licensing and delivery model in which software is licensed on a subscription basis and is centrally hosted. SaaS is also known as on-demand software or web-based software or web-hosted software as well. To make it simple to understand, let me give you an example. Have you ever used Gmail? Yes, you heard me right. Gmail is an example of SaaS or software as a service. So ask yourself what exactly you manage in Gmail. Do you know which server it is hosted on? Or what is the underlying hardware? Where is the database? What is the middleware or the runtime? Well, I'm sure like me, you don't know it either, unless someone of you has the insider knowledge. So in case of Gmail, we are not bothered about any of these details. In fact, this is the beauty of SaaS. Use it, consume it, and that's all what you need to care about SaaS solutions. It's just like a pizza that is delivered at your home. You don't know where it was baked. How was the pizza dough made? What is the exact making process? All you care about is the taste, and of course, you just pay for it. For a better understanding, let me share some examples. Here you can see that in IaaS, we have Microsoft Azure virtual machines, Amazon EC2 and Google Compute Engine. Then in the PaaS side, we have Azure Kubernetes Services, AWS Lambda and Google App Engine. And lastly, we have SaaS, which contains services like Gmail, Slack and Microsoft Office 365. Now that you have some examples of each computing model from all of the three major cloud providers, give yourself a chance to read more on each and understand them better. Many of these will be covered in the subsequent parts. So are these the only types of cloud? Well, yes, if you talk on a very high level, but when you take a little deep dive, there are many more. Let me quickly list down the other major ones. I will not go in details as this is out of the scope of fundamental course, but of course you should know all of them. So here comes the first one, which is called PaaS or backend as a service. So PaaS is a cloud service model in which developers offload or outsource all the behind the scenes aspects of a web or mobile application so that they only have to write and maintain the front end. For example, simply calling an API for authentication and storage without having to worry about the implementation or infrastructure. Then comes a similar concept of MBaaS, which is mobile backend as a service. So friends, mobile backend as a service is a cloud computing architecture that provides mobile application which access to the servers, storage, databases and other resources they need to run. We then have desktop as a service or DaaS, which is a cloud computing offering that securely delivers virtual apps and desktops from the cloud to any device. Here I quickly want to add that DaaS conceptually is very same as VDI but different in the implementation. With VDI, an organization deploys virtual desktops from its own premises data centers, and DaaS is essentially the same thing, but this one is on cloud infrastructure. Moving on, here comes container as a service or CaaS. So CaaS is a cloud service that helps manage and deploy apps using container-based abstraction. And please note that CaaS can be deployed on premises or in a cloud. I will share more details on containers and Kubernetes in the upcoming parts. And then we have very interesting function as a service or FaaS, which is a serverless way to execute modular pieces of code on the edge. The next one is storage as a service or STaaS. Now storage as a service is a business model in which a company leases or rents its storage infrastructure to another company or individuals to store the data. And then we have artificial intelligence as a service, which is an end-to-end solution allowing businesses to use AI-based services they need on pay-per-use or pay-per-service model. Friends, would you believe if I told you that there is something which is called anything as a service or XaaS? Yes, trust me, there is a concept called anything as a service. Basically, it's a general category of services related to cloud computing and remote access. And in one sense, I can say that all the cloud services that you have read so far, all these comes under the category of anything as a service. So that was all on infrastructure as a service, platform as a service and software as a service. Friends, these are very important concepts of cloud solution. And one of the very first decisions that you would make when designing your solutions on cloud infrastructure. So make sure to understand it well. If any confusion, watch the video again and connect with us if you have some doubts or questions in the YouTube comment section or any other social media platform. In the next episode, we will start with the next section, section 2, which talks about describe Azure architecture and services. And please make a note that this section has 35 to 40% of the total exam weightage. Thus, it's no-brainer to understand the importance of this section. And towards the end, my humble request to all my viewers, please appreciate our videos by pressing that like button. Your likes keeps us motivated and also help our videos to reach the right audience who want to learn Azure Cloud. Thank you so much for learning with us. I will see you in the next video. Till then, stay fit, keep learning and thanks for watching.
If this video has added any value in your learning, a like and subscribe is highly appreciated. Share this video in your family and friends to spread and expand their learning. Your comments and feedback give me a chance to interact with you and I look forward for them. We will meet again in our next video. Till then, stay fit, keep learning and thanks for watching.